So welcome to another session of Everyday Mathematics. Today we look at two problems, problems 22, 23 of the MIT Integration B Qualifying Exams 2010. And the first problem, 22, is the definite integral from x equals to 0 to x equals to 1 of x to the power 3 all times e to the power x squared. Problem 23 is the definite integral from x equals 0 to x equals to 1 of the square root of 1 plus x times the square root of 1 plus x times square root of 1 plus x times square root. So nested, infinitely continuing square root signs all over the place. So very interesting problems. I hope you hang out with us, and then yeah, we solve these problems. Thank you. On to problem 22, as we said, this is the definite integral from x equals to 0 to x equals to 1 of x cubed to the times e to the power x squared. And so we, it's a very interesting plot, obviously. E to the power x squared would be something like this. At 0, you have the inflection point, and then so this is e to the power x squared. But then when you multiply x cubed, suddenly this part here is forced to 0, and then the positive on the negative side of the x-axis, right? That gets also forced towards the negative, so you have a decent plot like that. Let me do a better job of drawing that. I don't want anyone complaining. So something like that. But now we have this region 0 to 1. So this is what we're going to try and integrate. So this is x cubed ex squared. Okay? Okay, so this is what we have. Now, the first thing I would like to do is substitute for x squared. So I would just say let u be equal to x squared, and that means that the derivative of u with respect to x is 2x, and what this means is that we can substitute using du, we can substitute for twice x dx. Another thing we have to look at is the limits. So x and u, when x equals to 0, 0 squared is 0. When x equals to 1, 1 squared is 1. So in other words, if we rewrite our integral from x equals to 0 to x equals to 1 of x cubed e to the power x squared dx, we can rewrite it in a way that is like this: 0, 1, x squared e x squared 2x dx. This 2 and this 2 is supposed to cancel, and then we want to write this in such a way that we could substitute with that. So that essentially becomes a half integral from in the u domain 0 to 1, x squared is u, squared is u, and then 2x dx is du. And that is our new integral. And that now is more tractable. We can now solve that very easily. So if we're to rewrite our problem as being half the integral from u equals to 0 to 1 of u to the power e to the power u du, we can use integration by parts, where if you have a product of capital U d capital V, that's the same as uv minus the integral of the product of v and d capital U. So here in this integral, if we take small u here to be capital U and v to be dv to be e to the power u, and since the derivative of e to the power u is the same as e to the power u, then we would say v is the same as e to the power u. So in essence, half the integral from u equals to 0 to 1 of u to the power eu du is the same as half. Now we've integrated, we have e to the power u, limit 0 to 1, minus a half. The integral, the derivative of u is going to be 1, and so we're just left with e to the power u, 0 to 1. So this is the same as a half on the upper side. As when u equals to 1, we have 1 times e to the power 1 minus, when u equals to 0, this is 0 times e to the power 0, so which is 0 minus half e to the power u, 0, 1. That's the integral of e to the power u is going to be e to the power u, and so this becomes a half times e minus a half on the lower side. On the upper side, it's going to be e to the power 1, which is e, minus on the lower side, e to the power 0 is 1. So we see this and that cancel, so we are left with negative. This becomes a half as our answer, and that was what was required. Okay, so we're going to move forward and solve problem 23, but that was an easy problem. So problem 23 is a little bit more interesting, and I hope we do stay locked and enjoy it. So this problem number 23, it's a very interesting problem. We have nested square root sums all across, but we can kind of work on it in a simple way. So if we say if we set y to be equal to the square root of 1 plus x times the square root of 1 plus x times the square root of 1 plus x, and so on, such that if we say y squared is equals to 1 plus x, and then we see that this part here is the same as y. So in other words, y squared minus 1 would be equal to xy, and so y minus 1 over y would be the same as x. And then we can say, if we differentiate both sides, 1 minus 1 squared, that is plus squared bracket dy dx equals to 1, and so we can now say 1 plus 1 over y squared dy can be used to substitute for dx, right? And then the harder part now is trying to figure out the limits, but that should not worry us. So since we say that y squared is equals to 1 plus xy, using the limits, as we can see, when x is 0, y would be, so this goes to 0, y squared is 1. We're going to take the positive side of things because looking at the square root, we're given the radical to be equal to y, not squared. So when you're beginning with a radical that is a positive, so you've got to stick with the positive side of things. So we have 1. Same thing happens when x equals to 1. Our equation becomes, so y squared minus y minus 1 equals to 0, using the quadratic equation. So we're going to y is equals to minus b, which is going to be 1 plus minus square root of 4 squared b squared 1 plus minus 4ac, which is, so this becomes 5 over 2. But mark you, we want the positive side of things, so our y of choice will be 1 plus square root of 5 over 2. So this becomes 1 plus square root 5 over 2. Okay. So let's now go and try and solve this equation. So the integral from x equals to 1 to x equals to x equals 0 to x equals to 1 of the square root of 1 plus x square root of 1 plus x square root of 1 plus square root. This is the same as we saw. The lower limit was 1, the upper limit was 1 plus root 5 over 2, and then this entire part is y, so we have y, and in place of dx we saw that we would have 1 plus y squared dy. So this becomes 1 to 1 plus root 5 over 2 y plus 1 over y. And so quickly come to an integral of y squared over 2 plus natural log of y from 1 to 1 plus over that. Okay, so that is, it's getting better. It's getting better. Since we have our equation as y squared over 2 plus natural log of y into 1 plus root 5 over 2, this is the same as 1 plus root 5 over 2 squared over 2 plus natural log of 1 plus root 5 over 2 minus 1 over 2 plus natural log of 1, which tends to 0. Okay, so here what we have is 1 plus 2 root 5 plus 5 all over 4 2 log of 1 plus root 5 over 2 minus a half. Okay, so this plus this becomes 6. 6 divided by 8. So we have 6 divided by 8 plus root 5 over 4 plus log 1 plus root 5 all over 2 minus a half. Okay, how do we simplify this further? It's I mean, when we take 6 over 8 minus a half, which is 8, 6 minus 4, which is going to be 2 over 8, which is a quarter, and so we have 1 plus root 5 over 4, considering this, plus natural log of 1 plus root 5 over 2. And that is our answer. Yeah, so, well, thank you so much for hanging out with us. I hope you do enjoy following along. Until next time, bye-bye.